Hello viewers, you are welcome to our channel once again. So today we are going to talk on functional group. Remember, we'll be running a series on organic chemistry. In our previous video, we talked about homologous series, but in today's video, we are going to be talking about functional group. So in case you are finding organic chemistry difficult, this is an opportunity for you to learn the details of organic chemistry, from the scratch. Okay, click subscribe button and then on the notification button so that once we post in video, you can get a first-hand information and then you can get value from our videos. Okay, so let's get down to this. So, what is functional group? When we talk about functional group, what are we talking about? Now, when you come to organic compounds, we have different homologous series, as we have talked about before. Now, these homologous series are families of organic compounds, and each organic compound behaves the way each family member in that organic compound behaves. Okay, and what determines how every organic compound behaves is what we call the functional group. The functional group. Now, functional group is one of the things that also determine a homologous series, because each homologous series have a distinct functional group. So what is a functional group? We say that a functional group is a substituent in a molecule that causes a molecule's characteristics chemical reaction. That's to say that the functional group in a molecule is a group. Okay, it can be either it can be a hydroxide group, it can be a C double bond group or a C triple bond group, or it can be an amino group. Just any substituent, any chemical substituent attached to an alkyl group in an organic compound that gives that particular group its function, or that helps it to react the way it reacts chemically, or gives its chemical properties. That particular group is what we refer to as the functional group. Now, what are examples of functional group? We have so many examples of functional group. Number one, for example, is we have the OH group or the hydroxide group. Then we also have the amino group, and we have the carboxylic acid group, that's the COOH group, and then we have the Cl group. Now, when we talk about functional group, any substituent that determines how that particular group molecule will react chemically is a functional group. And the whole group 7 elements, when they substitute hydrogen atom in maybe an alkane, and then they determine how that particular compound will behave, we say that it is a functional group. So for all the group 7 elements, they are represented as X, and when we represent them as X, it can either be a chlorine, or it can either be a fluorine, or iodine, or any one at all of the member. Okay, so each of them that displaces a hydrogen atom to give that particular molecule its chemical property, we can say that that's the functional group of that particular molecule. Okay, so let's take a look at this table. Let's take a look at this table. Here we have carefully arranged on this table the homologous series, and then arranged the general molecular formula for each group of organic compounds, and then here we have the functional group. That's the substituent that gives it its chemical properties, that gives organic compounds their chemical properties. So the first one we have is the alkane family, or the alkanes. The alkanes. Now the alkanes has no functional group. The alkanes has no functional group. That is to say, the alkane family, they are relatively inert. They don't really react much. They are relatively inert, so they don't have any functional group. Then the second one we have is the alkyl group. The alkyl group. Now, the alkyl group is any member of the alkane group, be it methane, be it ethane, be it propane. As once you remove a hydrogen atom from a parent alkane group, then you have an alkyl group. So when you have an alkyl group like that, then the functional group is always that parent alkyl group. Okay, so here we have R. This R represents an alkyl group. Okay? So the third one we have there is the halogen or the haloalkanes. The haloalkanes. Now the haloalkanes, their general molecular formula is represented as Rx. The R representing the parent alkyl group, and then the S representing the halogens. Okay, so that's why you get it treated as X represents fluorine, or S can be chlorine, or S can also be iodine, or S can even be bromine. Okay, so here, so that is to say that if you now go to the functional group, the X, that is either the chlorine or the fluorine or the iodine, is what will now give that particular molecule its chemical property. So either of them is the functional group, and that's why we have X here to represent the halogens as the functional group for all haloalkanes. Then the fourth one we have here is the alkanols. The alkanols. Now, the alkanols is also known as alcohol. You know, mostly every time we hear alcohol, what comes to our mind is the one that we consume. Okay, what comes to our mind is ethanol, but ethanol is not the only alcohol. We have so many alcohol. Most of them are not edible. We don't consume most of them. Majorly, what you consume is ethanol. Okay, so alcohol is a homologous series, and the functional group for alcohol is OH, the hydroxide group, the OH group. So we have the methanol, we have the ethanol, we have the propanol, we have the butanol, we have we have the hexanol, and so on and so forth. Okay, so the fifth one is we have here is the carboxylic acids. The carboxylic acid. Now, the general molecular formula for carboxylic acid is RC double bond with O, then the single bond with OH. So this is the carboxylic acid general molecular formula. R representing the parent alkane group, and then the COOH representing the functional group. So that's why you have it here, that the functional group for this is COOH. Okay, so another functional group for ester is the COO. So, you know, in ester, we have an alkyl group R attached to C double bond O and CO again. Then here is attached another alkyl group R prime. Okay, so the functional group for the alkyl for the ester is COO or R. And then we have the primary amines. The primary amines his general molecular formula is R, that's the active group, bonded to the NH2 group. So here, the functional group, that's the substituent that determines the property, the chemical property of the primary amines is the NH2 group. And that's why we say that the functional group is NH2. So these are some of the examples of functional group. So if you did not learn anything, you just know that functional groups is a group or a substituent in any molecule in organic chemistry that determines their chemical property, and that is what we call the functional group. So this is where we will draw the curtain for today. So keep a date with us as we keep this series on organic chemistry. Now, if you are new to our channel, just click subscribe and then on the notification button so that the next video we post, you will not miss out on it. So see you in the next video.